So what I want to look at in this lesson is the idea of what are called equal volumes. So equal volumes. So equal volumes. So one example of this is if we took, let's say we had a container that was something like this, and it contained a volume of water, and we poured that water into a longer, shorter container, something like let's say this. Okay, they've drawn this in great, but just bear with me. So if we start off with a volume like this, and we pour it into a container that has a shape like so, these volumes are going to be equal to each other. The same thing happens as well. So if we take something like this, so let's say we have a volume of water that's in a cylinder, and we take an object, a solid object, and we submerge that solid object into water. What's going to happen is it's going to displace its volume in water. So imagine, let's say this blue line here is the volume of the water before the object is put into it. When you put the object in, the water will rise a height of h, and the volume here, the volume of water that has risen, let's say above the original point, that volume is going to be equal to the volume of the object that was put into the water. So again, this is the idea of equal volumes. And sometimes what you can be asked to do is you can be given shapes like so. So we have a cylinder and we have a sphere. And what you could be asked to do is you could be asked, for example, to work out the height of water that is submerged based on the volume of the sphere and the volume that you started off with that was in the container as well. So in this case, what we can do is we can use this idea of equal volumes. So if we remember, so if we take the cylinder, so the volume of a cylinder is equal to pi r squared multiplied by height. Okay, so that's the volume of a cylinder. And then the volume of a sphere the formula that we use for it is equal to 4 over 3 pi r cubed. So it's equal to 4 over 3 pi r cubed. Now what we are being asked to do here is we're being asked to find this height here. So what we can do then, in order to work out this height here, what we can do is we can use this principle of equal volumes. So in order to get the volume of the sphere, we can use this formula here, and we have everything we need. We have the radius for the volume of the sphere, to work out the volume of the sphere. That volume is going to be equal to this volume that was displaced. And what we can do then is we can use the volume of a cylinder. Okay, we have the radius of the cylinder, which is 6, but the height is going to be unknown. And we can make these formulas equal to each other, and we can put in what we have, and therefore we can work out the height here. So what would that look like? So we can have something like this. So we can use, so let's say, so we can have 4 over 3 pi r cubed is equal to pi r squared by height. And then what we can do is we can work out these values here. So if we focus on the volume of the sphere, the radius is going to be this here. So the radius is 3 centimeters. So this would be, we'd write this as, so it will be 4 over 3 pi times 3 to be squared, or cubed, should I say, 3 cubed. Okay, that's coming from there. And then if we have a look at here, so we have pi, so let's just keep this in blue, so is equal to pi times the radius of the cylinder. So the radius of the cylinder is this guy here. So it's 6 squared times the height. Okay, and the height is unknown. We don't know what it is, and that's what we want to try and work out. That's wrong. So times the height. Okay, so what we can do is we can let one volume be equal to the other, and we use the principle of equal volumes. So what we can do then is we can work this out. So 4 divided by 3, so 4 divided by 3 is equal to 1.32, and we'll just round it to, let's say, just 1.3. So this is going to be equal to 1.3 multiplied by pi multiplied by 3 3s are 9. So let's do this. So 3 by 3 by 3. So 3 multiplied by 3 multiplied by 3 is equal to 27. Multiplied by 27 is equal to pi times pi multiplied by 6 times 6. So 6 multiplied by 6 is equal to 36. 36 multiplied by height. So what we can do then is we can multiply this out. So 1.3 multiplied by pi multiplied by 27, that's equal to 100, so let's say 110.2, so we'll just round it up to 110, so that's equal to 110, so it's equal to 110 is equal to pi times 36 times height. So let's work that one out. So pi multiplied by 36 is equal to 113.09, so we'll just round it to 113, is equal to 113 times h. Okay, so then what we want to do is we want to find out then what h is. So what we have to do is we have to try and get this h on its own. So in order to do that, we have to divide this side by 113 and divide this side by 113. And what will happen is these will cancel out, and h will be equal to 110 divided by 113. And if we work that out, so 110 divided by 113, 110 divided by 113 is equal to 0.97. We can just round that up to 1. Okay, it's equal to 0.97, let's say centimeters, and we can just round it up to 1 centimeter. So what we've done is we found out that h here, h is equal to 1. So again, what we're doing is we're using this principle of equal volumes, and we get the volume of the cylinder and the volume of the sphere, we make them equal to each other. We put in the values that we have, and then we work them out, and we found out that the height here is 0.9 centimeters, roughly 1 centimeter. And we know this because the volume of the sphere will displace its own volume in water, and that's the water that's been displaced here, and that's the height. So that's equal volumes. Again, you can have many other different variations of this with different shapes, but it all kind of boils down to the same thing. Basically, all you have to do is just let one of the shapes volume be equal to the other, and then from that you can work out whatever the question asks you for. In this case, for the height of our displacement. So hopefully that makes sense, and thank you for listening.